Hello and welcome to this session of the KnowTalks series, a series that was put together in collaboration between the UNDP and the Mohammed bin Rashid Foundation, basically bringing together the world's top names and experts and knowledge experts to talk about and discuss brilliant, innovative ideas to solve the most pressing problems that are facing our planet today. Today's session is titled Innovate or Die Trying, a pretty unusual title for an unusual guest as well. He's anything but your traditional innovator, thinker, inventor, and hacker. Here are some of the projects he's actually used to venture and use technology to solve some of the problems in cybersecurity. He's worked on spaceships with Jeff Bezos' company. He's worked and used advanced technology to stop the spread of diseases. He's worked on 3D printers way before I heard they existed. He's worked in projects in energy consumption, recycling, robotics, and he has at least 70 inventions, so 70 patents registered under his name. He is currently using artificial intelligence and advanced technology in the lab where he, in Intellectual Ventures Lab, to work on these, stopping the spread of pandemics and diseases. Basically, Pablos Holmen has said that he's warned about the spread of pandemics for years now, but it just is the case that we humans don't really worry about these problems until, well, it might be, until it happens, which is exactly what happened now. A few housekeeping notes. This session with Pablos is going to be divided into two parts. The first part will be his notes that he's prepared for us today for about 20 to 25 minutes. And the second part of the session will be a very interesting workshop between Pablos and three industry executives where they get to basically take his advice on how to grow and promote their industries and their services and their company. Pablos Holmen, also a very known hacker, says that he's grown or he has developed a special way and a relationship with computers because he got a computer at a very young age. He was almost 9 growing up in Alaska. And this is how he taught himself how to program and code and talk to computers. And here he is today speaking to us at this session on how to use technology to solve some of our problems. Pablos Holmen, I don't want to say the floor is yours. I'm going to say the mic and the fancy webcam you have is also yours. So go ahead.
Hi there. Hi, you guys.
Hi.
Well, thanks so much.
You. Sorry, I just have one quick reminder, since your Arabic is not so good, you said. I wanted to remind everyone that we do have simultaneous translation into Arabic. The option, if you want Arabic translation, is down there on the menu under interpretation. Just click the Arabic and you will hear it. If you don't see it next to the Q&A, just log out and log back in again. It's all yours, Pablos.
Awesome. I'll work on my Arabic so next time I visit, I'll be better.
Good luck.
So first thing I want to do is get you guys to take a look at this chart. You know, this is the history of humans on planet Earth. So not very many of us. About 160,000 years ago, you get the first Homo sapiens. And then it's just thousands, hundreds of thousands, millions. And not until the last couple hundred years did we hit that hockey stick growth curve and go from millions to billions almost overnight. And it's that curve that defines everything we're experiencing in the world today. I think it's really important to put our experience and our problems and our work in context. So what happened along the way? Well, along the way, we invented solutions to a lot of the hard technical problems that kept humans from thriving. How do you feed all those people? How do you give them jobs and give them homes and eradicate the diseases that are killing them off, right? Well, did you know that 400 million people died of smallpox before we invented vaccination, right? Humans have the capacity to invent new technologies, bring them into the world and solve problems at a larger scale. But to do that, we have to try. And if there's one thing all these extra humans are good for, it's making more problems. So our job is to figure out how are we going to invent on that scale? And how are we going to innovate and bring those technologies into the world on that scale? And that's the challenge that's ahead of us. So I want to talk a little bit about what that process is like. And as an inventor, a lot of times what I'm trying to do is just add tools to the arsenal, figure out if there are new technologies that we could use to solve those problems. So I want to talk about some of those to give you guys a sense of what's really possible. So a lot of what we're doing these days is using giant supercomputers like this to analyze a lot of data. And it's really important, I think, to get our heads around this technology because if we don't invent anything else for the rest of our lives, we're going to be kept busy just applying all the superpowers that we've gotten recently from machine learning. There's so much we can do and we can apply this to every industry. But I want to give you an example from our lab of what we were able to accomplish. So take a look at this. Oh, can you see my slides there or did I freeze up?
Yeah, it's a little frozen on the, we can see the photo of the computer still.
That's not what we're trying to do.
That's okay, technology happens. I wish I could help.
We're gonna see if we can fix that.
Yeah.
Hold on one second.
No worries.
Oh, we lost our cameras. Ooh.
Pablos and I were just talking about this before he started. I was just telling him how we not only as moderators and speakers have to worry about our content and preparing right with the guests and writing the questions and making sure the audience is aware and engaged. We also now have to worry about technology not serving us or just falling on live like it happens. Your camera might break, your audio might go away, your slide might freeze, your kids might walk into the office and interrupt you.
You guys see this video?
Yes, we see
so
a
this
video.
This is a computational model of the spread of disease. And we often create models like this for different diseases. This is a computational model for the spread of malaria in Africa. So we collect data on the climate, on how much rain there is, the travel of humans, all the kinds of things that can affect the spread of the disease. And then what we do is we put it in a giant simulation. It's kind of like SimCity or some other video game. Here we're testing in Madagascar. So if you go to Madagascar, you might want to go to the middle. That's actually where the people still are. In the rainy season, malaria covers almost the entire island. In the dry season, it goes away almost completely. But the point is, we're able to test our interventions thousands of times in software before we ever do it in the real world. And that kind of possibility is unprecedented for humans. You know, in all of human history, we're only able to run one grand experiment, which was, you know, the one we ran in the real world. But now we can test all of our possible futures in software and choose from them which future we really want to go for. And that's an amazing superpower that humans have now that we've never had before. And I think it's applicable to almost every business, every industry, and really almost every problem that humans are taking on. Here's another example. Just using the capabilities from artificial intelligence, we've been able to, oh, are we having a problem here?
Yeah,
there we go.
Oh, okay, now we see.
Wrong slide. Yeah, we're able to use the same kinds of computational modeling tools to build an AI diagnostic that can look at blood. This is a blood sample that's a diagnostic for malaria, but it's very similar to what you might do for other diseases as well. And what's happening in you know, most of the time is a human is going to look through a microscope at a slide like this and try and figure out, you know, is that the malaria parasite living in a red blood cell, or is that some other crap in your blood? And the truth is, it's very difficult, and humans aren't really very good at it. But we were able to build an automated microscope that's able to take a pinprick of blood, just like a diabetic might do, and it takes a 0.5 gigapixel of photos of the blood sample. And then from that, It's able to using machine learning algorithms, it's able to go and analyze all those images, and it outperforms the best humans on Earth. We've been able to apply this to diagnose other diseases as well in a way that's scalable, cost-effective. This is important. With malaria, you have asymptomatic carriers, and they're traveling around, spreading it to places you already got rid of it. About 700,000 people a year now die of malaria. Half of them are kids under 5 years old. So you really want to be able to ramp up diagnostics. You want to test people so you can treat them. And this is very analogous to how you would attack other diseases like COVID. So take a look at this stuff. This is kind of interesting. If you had a soup can full of depleted uranium, it would contain as much energy as $12 million of gas at the pump, right? It's incredibly energy dense, but the stuff is radioactive and dangerous and messy, and we don't know what to do with the waste. So we've been saving it for our grandkids and stockpiles, hoping that they'll figure out what to do with it. So we invented a new type of nuclear reactor. It's powered by nuclear waste. Now, that's something that hasn't been possible before. What a lot of people don't realize is today's nuclear reactors were designed before we were born with pencils and slide rules. They're only 0.7% efficient. 99.3% of the energy is still in nuclear waste. Well, our reactors can get the rest of that energy out as well, right? So what people don't realize is it's possible to do better, but we have to try. We design our nuclear reactors on those giant supercomputers. We can model all the neutrons in the reactor core. We can understand what's going to happen before we build these things and make modern, safe reactors that are dramatically more efficient. Look at this. This is a stockpile in Kentucky, here in the US. 700,000 metric tons of depleted uranium just sitting on the surface of the earth. We've been saving it for our grandkids. We have no idea what else to do with it. It's left over from making bombs and making reactors, right? With our reactors, with that one stockpile, we could power the entire planet, including growth, for about the next 1,000 years. We don't even need to mine uranium, right? We can do better on these things, but we'd have to try. And we haven't really been trying. If that's not good enough, take a look at this. This is a prototype of a fusion reactor. Now, we've never been able to make fusion work. Fusion is pretty much the holy grail of energy. It works in a sort of the opposite manner of fission, the way today's nuclear reactors work. Fusion is what the sun is doing, right? And for our whole lives, we haven't been able to figure out how to sustain a fusion reaction here on Earth. But you know what? Now we know. Now we've solved all the scientific problems. And modern companies like Commonwealth have figured out how to make reactors like this. We're at the beginning of building them, but we'll be able to make reactors that could power you for your entire lifetime off a single glass of seawater, right? Think about what effects that would have on your business, on your industry, right? You sick and tired of hearing about these guys yet? These are the poster children for disruption, right? Well, think about companies like Uber. You know, what did Uber invent? Yeah, not really anything, right? What did Airbnb create? New technology? No. These are not actually technology companies at all. These are just opportunistic companies who figured out how to take the technologies, the actual technologies built before them, you know, wireless data, mobile phones, smartphones, you know, the things that were really long and hard and slow to build, and use them to not only make a better business, but to replace an entire industry, right? That's a really important lesson to understand, because with Silicon Valley, when we figure out how to do something better, we figure out how to fund it to go global overnight, right? And so it's really important for a lot of businesses to start thinking about, okay, what technologies might change your business? Right now, you could maybe have some barriers to entry, like, you know, you've got all the customers, you've been around for a century. There might be some regulatory environment that makes it hard for startups, but you know what? That's been true in a lot of businesses, right? How many taxi companies could have made an iPhone app, but didn't? The answer is pretty much all of them, right? But instead of looking ahead, looking for those technologies that could make their business better, could make their product better, could change the industry to do it better, they went down kicking and screaming. They fought Uber at every city hall, at least in the US and in other jurisdictions as well, right? They tried to block these companies that were actually providing a better service. So before that happens to you, and it might, right? You get a chance to decide, do you want to be the innovator? Do you want to be the one to figure out how to change your industry, to change your business, to go out and do it differently or better? And what technology drivers you could use to do that? Or do you want to be the one left behind by the next Uber, the next Airbnb, the next Facebook? So I want to break that down and give you guys an example of what this, what this looks like. We're going to pick on the fashion industry just for fun. It's always fun to make fun of other industries because obviously they're bigger idiots than you are. So if you're a fashion designer, think about the product cycle, right? You design something, you send it down the runway, right? You take some orders, you send a fax off to China, you wait 5, 6, 7, 8, 9 months for it to come back on a boat. You put it on the shelf, you try to find some customers, and you hope you guessed right about what colors, what designs, what sizes, and the volumes, right? Now, nobody ever guesses right about all those things. And that's inventory risk, right? If you guess wrong and you made too many of something, well, that's liquidation sales, that's disposal, that's brand devaluation. If you guessed wrong and didn't make enough, then you're leaving money on the table and opening up the opportunity for competitors to step in, right? It's really hard. Everybody in that industry has battle scars from guessing wrong, right? So you probably have battle scars like that from your business too, something similar. Well, think about this. Think about how we make software. Back in the 80s, the way we made software is we would dream something up, roll out of bed, write some code for about 18 months, put it on a floppy disk, ship it to a computer store where somebody could buy it. The box, inside that box with the floppy disks was a postcard. It was literally a postcard where you could write bugs with a pencil, lick a stamp, mail it into Microsoft or Apple or Adobe, and they would fix the bugs. And on the next version, 12 months later, your bugs would be fixed, right? We made software on the same 18-month product development cycle that we use to make clothes and sunglasses and sneakers and cars, right? That product cycle is too long. It requires too much guessing. Here's how we make software today. I dream something up, I roll out of bed, write some code, launch it at lunchtime. All afternoon, people are emailing me, pissed off that it doesn't work on their Android phone. I fix some bugs, launch another version, go to dinner. Fix some bugs, launch another version, go to bed. 4, 5, 6 versions a day are normal. That's your web apps, that's your mobile apps, that's how we make software. And it's that rapid iteration that makes us so powerful. When we say software is eating the world, it's almost exclusively this dynamic, right? This rapid iteration means we don't have to be so smart. We act like we're super smart, but the truth is you got to be smart to guess a year in advance what the market wants, right? If you're just going to A/B test your way to success and steer every day, you don't have to be so smart. That's how we're cheating. I'm trying to be candid about this and show you guys how we think, not because we're right, but to give you a chance to figure out how you can do better, right? If you think some of these ideas could work for you, great. If you think you can do better, that's even better, because we're trying to figure out how to make everyone on Earth capable of advancing into the future, adopting technologies and building with them even better than we've been able to do in Silicon Valley. So if we have self-driving cars, we have surgical robots, how long do you think it'll be before this exists? What do you see missing in that video? Yeah, this is a prototype. It's not real. There used to be somebody driving that machine though, right? No miracles are required to make that machine. You know, right now, everything you've ever worn was sewn by human hands in some factory dungeon somewhere. China doesn't even seem to want to make clothes anymore. They're having Bangladesh make their clothes, right? We're running out of places on Earth to get cheap labor. So I'm just trying to paint a picture for you, right? Someday soon, maybe 3 years, maybe 5 years, somebody's going to create that machine. When that sewing robot exists, you'll see a sea change. In a $2 trillion industry, every human on Earth is a customer, right? And somebody's going to figure out how to do it better. So look, I'm just trying to paint a picture so you can imagine for yourself, what's the analogous thing that's going to happen in your business, in your industry that you know about, right? How could it be taken over? How could it be replaced? If you were starting from scratch today using these technology drivers, how would you rebuild that business? So if you have an iPhone in your pocket, the cost of that thing is equivalent to the global median income, right? I'm not trying to make you feel bad. I got piles of these things. But what I think is important to understand is that the world has kind of overinvested in a lot of us, right? More education is spent on me, more money was spent on me, more jet fuel has been spent on me, right? And what I think it means is we need to do what we're uniquely good for, right? We need to figure out not just how to make a product like that for rich people, we need to figure out how we're going to take it to the rest of the world, right? That's hard. It's harder than making a product for yourself. It's harder to understand a problem that you don't even have, that a billion people have, right? And that's where a lot of the opportunity in the world is right now, is to figure out how we take these technologies and use them to raise the living standard of everyone in the world. I want to give you an example. This woman is packing $25,000 worth of vaccines into a crummy styrofoam cooler that costs $2. And she's going to truck them out into the bush in rural Africa, start injecting kids. And about half of those vaccinations are going to fail. They're going to fail just because they didn't stay cold. About 20 to 50% of the vaccinations fail. And about 250,000 kids a year die of something they were vaccinated against. We manufactured the vaccines, we transported them out there, we trucked them out into the bush, we injected those kids, and then they still didn't work. And the reason is just they didn't stay cold. Now, I don't have this problem. I have a refrigerator. I've got power that works 24 hours a day. My kid's vaccinated, everything's cool. But for billions of people on this planet, we don't have that kind of infrastructure. We don't have consistent power. The power is out 4 to 16 hours a day in a lot of places in Africa, right? So we invented this thing. It's a kind of super thermos. You stick your vaccines in there, put it in the sunshine, in the Sahara, with no external power. And you can come back a couple months later and your vaccines will still be cold. There's no power cord, no way to plug it in. It just stays cold. It wasn't really that hard for us to build either. I want you to look at this. This is the actual deployment scenario. You strap this R2-D2 looking thing to a camel, walk for days into rural Ethiopia, set up a clinic, which is literally just, you know, a tree with a doctor under it and one of these things, right? Injecting kids. That's the front lines of vaccination. This is how we save millions of lives this is the reason you and I exist. That's the truth, because of vaccination, right? So what I think is probably, you know, for our team, you know, we got a lab full of PhDs in biology and chemistry and all the things you would need to do, physics, to be able to create an invention like that. Probably that's not as true for the guy leading that camel into the bush right now, right? I just think it means we need to do what we're good for, what we're uniquely capable of doing. What can we do to create these technologies, to bring them into the world, to solve a problem for 1 billion people and become better ancestors? Leave behind a world for our kids is better than the one that our parents left for us. So that's what I had to share with you guys today. What we want to do next is spend a little time talking to some folks from different industries. And I just want to give you guys an example of how I think, not because I'm right or because I'm smart or better or anything like that. I want to just show you the thought process and give you a chance to understand how I would think about reinventing different businesses and industries. And so I'm hoping that we get a chance to have some good conversations here. And
what you showed us is pretty amazing. And although you make it sound easy, I'm sure business leaders are wondering, how can we simply just say, okay, here's the problem that I have. Here's the problem my consumers or my constituents have. And here are some of the options I think I could solve it if they were not in the technology sphere, or they're not tech savvy as you are. So it's very interesting now to take some of the amazing stories you told us from that sector and try to apply it to the purely business sector. Let's see how we can start this workshop. Basically, I have 3 names. I'm gonna start with the first one. The first executive I have is Dr. Mohammed Shahtout. He is from Emirates Steel. Okay, you know the enterprise, you know the industry, you probably know the challenges that they face. They are UAE's largest industrial conglomerate. So let's see if Dr. Mohammed can hear us. He would like to have his session with you. I think we'd like to see him. He'd like to be on camera, correct? Dr. Mohammed, are you there?
Yes, I'm there. You can hear my voice?
Yeah.
Yes, hi. Yeah, nice to meet you, Jessy and Pablo.
Yeah.
Ahlan, you're very welcome. Here's what we're going to do. Since you are the first in this trial, which is so exciting, I'm going to give you 10 minutes where you can ask Pablos anything you can about your industry and maybe give him an insight into the challenges you are currently facing and the goals you want to achieve. And I will come back to you in 10 minutes.
Okay, good. So good afternoon, all.
You guys are in the steel industry, is that right?
Yes, we are in the steel industry. We are Emirates Steel. We are producing almost 3.5 million ton per annum crude steel. We are the only integrated steel producer in the United Arab Emirates. So you know very well the steel industry and the challenges we have nowadays. Starting from the balance between the supply and the demand for the steel industry, then the China battle for the market economy status for the steel, producing the steel and importing it to UAE with the cheap prices. Also, we have problem about the price of the raw material, which is fluctuating due to the current situation worldwide. Also Paris Agreement for the environment, which will give more regulations for the emissions, carbon dioxide emission, dust, many things. So these all are a huge challenge to the steel industry. I think we took some initiatives from our side in Emirates Steel, and I think that the steel industries, the companies, should work, as you said, on the research, on the innovation, because without that, we will not succeed. We will not success also. And this will help to reduce our capex, our opex. This will enhance our output, productivity, products, new products, and at the end, this will give will be efficient to the industry and economically viable.
Wow. Well, let me try and
my question to you. Yes. Okay, Pablo.
Well, I'm curious. So, on one hand, I guess managing supply and demand for you isn't quite as bad as it would be for, say, produce, right? Because if you overproduce, at least the product keeps for a little while. But I wonder. I mean, I suppose maybe there's some limit to that because you're such a large scale operation. Storing produced steel is not a good business to be in either. So that's one thing. I think I would look at that as kind of an advantage over other types of industries. But what I think is interesting about steel, and you could correct me because I know obviously a lot less about it than you do. One of the issues I've seen historically is the product is very inconsistent. And when you look at how the way everything is going in construction and how we manufacture other products, and I would look at like electronics as an example. The more standardized and consistent and precision a product is, the easier it is to be used over and over again in a variety of different applications. And with steel, it seems like every time you get a beam, you've got to spend a lot of time banging it into place and cutting it and reforming it just to use it. And there's no standardized product. And I'm curious if you guys have looked at that as a way of changing your business so that you could actually, change what's happening downstream from you to make yourselves into a more in-demand producer. Because I see it really as being a bottleneck that's holding up a lot of other industries from advancing.
Okay, so you mentioned one important point. Even we took already progress on that, is to diversify the products, not only from the application point of view, but also from the varieties point of view, as a range, dimensions, grades, something like that. So we are doing that. But you know that it is not that easy, because you need to try and fail and succeed at the end, and then after that produce this new grades or new products. But your point is clear.
I didn't mean to derail you. Thanks for entertaining that. So what do you think is if you were looking, like, what do you see as being the technology that could help you the most?
Yeah, technology barriers, you mean? Yes, I need to ask you, and to also from your experience, to get some advice or guidelines. Nowadays, the Industry 4 era, and everyone is looking for the digitalization and the artificial intelligence. But we can build a very good artificial intelligence or digitalization system if we will go to a greenfield company or plant.
Yeah.
But to apply this or implement this to the a brownfield plant, it is not that easy. Because it will cost huge money for modification. Maybe the capex will be very high. We need to hire expertise. So what is your advice or guideline from your experience?
Yeah, so one thing, and again, I might be a little bit further out in the future than you're thinking, but what I see happening is actually going to change that, because what I see happening is we're getting to a point where, we have what you're describing is the difference between if we're building a new plant versus if we're, retrofitting an old one and we're trying to use technology to improve an old one. The nice thing that's changing is that we have the ability to create sensors for almost anything. We can go into an old plant with pretty much commodity sensors, just cameras. And before, we'd have to build a custom sensor to understand what's going on. But now we can just aim a camera at what's going on. And by camera, I mean, CMOS sensors, but you could even use them to sense all kinds of other things besides, that you would normally think of as visual. Now we can sense almost anything. And then before, what had to happen is you had to very carefully calibrate those things and make sure that they were sensing exactly the right thing in the same way every time. But now we're able to use the same machine learning algorithms that we use for everything else to basically just watch systems over a long period of time and then start to understand them. And that's where you're really going to start to get some of the gains, because now those systems can start to compare even a couple of factories that aren't exactly the same. They can start to infer what would be useful to improve upon. And I think that's been difficult to do in the past. As you know, in like a big industrial plant, you're putting a lot of sensing equipment in, but I think that way is slow, right? Because you had to have those highly educated people. You had to understand everything that was going on. It had to be very finely tuned. And in some sense, the sensor system you were using, the monitoring system, just to understand what was going on in the factory, was more error prone than the factory itself. And so now what I'm saying is, one of the really nice things about being in a world of machine learning is you can have a lot of crappy data and you can still come out with some pretty valuable insights. And so what I'm hoping is for factory operators like you guys, we're going to be in a world very soon where you're going to be given a much better toolkit to work with. You're going to be able to get those insights about how to improve the factory, how to make it more consistent, how to make it, what's failing over that you might not notice on a shorter time horizon, but over time, the machine learning algorithms are able to figure out what's actually going on. I'm being a little bit vague because I don't know your factory that well, but you got the idea. I'm seeing that happen in pretty avant-garde areas. And what I'm hoping is that industrially, it's going to make it more possible to look at all those factories as being the same, whether it's one that's only existing in CAD software or one you've been running for 40 years or one you're building. They're all going to be the same to the computer. Hope that makes some sense.
Yeah. Thank you.
So you have I wanted to take full advantage of Pablos. Dr. Shahtout, you have about 2 more minutes left. Do you think there is a difficulty or a challenge you are facing in your industry due to what happened recently in COVID-19 and the disruption it has created in the lines and supplies and demand? Do you think there's a specific difficulty that you think Pablos can help you change the way you're thinking about?
I think nowadays, due to this COVID-19, we have problems about the market itself for the steel. I mean, as I mentioned before, the demand is less. So we need to speed up, I think, to diversify or innovate some new products or grades to maximize the premium for our products. We need to work more on that. Yes, we are working, but this will be due to this COVID-19. We need to work more hard on that.
So Pablos, my question
fast. Not only hard, fast also.
Yeah, so my question to Pablos would be from someone who's not an expert on steel, but typically speaking, here's an industry, that's suffering from a decrease in demand due to all the conditions we know of right now. There's less demand on steel because there's less construction, there's less maybe money into it. So these are all the challenges. what is a disruptive way or different way you would think about it, aside from offering a different range of the product itself? Would you offer something completely different?
Well, one of the problems, I mean, one of the problems that we were kind of alluding to is that, you know, in order to improve, we're trying to use automation where we can, right? Automation in, you know, in manufacturing, automation in construction, but we're not really getting there. And one of the problems with, you know, the construction industry, which is the primary, you know, consumer of steel products, you know, they're held back in a number of ways. It's hard, you know, it's not an industry that likes to do a lot of innovation. A lot of times they're dealing with regulatory issues about what they can build and when and where. But all of that gets simplified if you can standardize on something. Right now, you often can't standardize on construction projects because everybody wants to build something unique, and the land that you're building it on is always unique. But to the extent that you can, you know, we use you know, standardized sheets of plywood, standardized lengths of boards and those things, and we're always cutting them down on site. But to the extent that you could make building constructing a building more and more like Legos, and you could expect the product to come and be consistent, and you could count on that every time, then you could design things that could be built quicker and more consistently. And so I think this is a difficult one because you're talking about an ecosystem where the real gains are going to be made downstream from you. And what we're looking for from the steel industry is how do you enable the downstream industries, the construction industries, to be able to improve what they do. And I think if you can, you know, understand their problems and show them something that they didn't even know was possible, that's where you're going to get the major gains. And in some sense, it's kind of like trying to think about creating a new market for an old product. So I would love to dig in deeper someday, and hopefully I'd have better ideas with more time.
No, we'll give you food for thought. You'll be thinking about it.
Yeah.
Thank you so much. That was Dr. Mohammed Chahtout. He's the Continuous Improvement Manager at Emirates Steel. Thanks a lot, and good luck to you as well. We're going to move on to the second industry and the second leader today. Our guest is Nadia Salim Mubarak from Abu Dhabi Ports. She's basically the VP of the ports sector. She is going to ask her questions via audio and not on camera. So you will hear her, but you will not see her. Basically, what I can quickly give you a brief is Abu Dhabi Ports is obviously the region's top facilitator of logistics, transport, trade, basically connecting Abu Dhabi to the world. They were founded in 2006, and now they own and operate and manage about 11 ports and terminals in the UAE and Guinea. They have a substantial amount of operation. I will let Ms. Nadia Mubarak give you a better insight. Can you hear us? I cannot. Hello, Nadia, are you with us? Okay, let's see. Maybe her mic is on mute or something. I will give her a few minutes to reconnect or try to see if there's a technical issue. Maybe I will go to, let's see if I should go to Professor Khalid or see, I don't see Nadia with me on the panel. Oh, okay, I see her on, but her microphone is not on. Nadia, if you can hear me, I think you're on mute. If you cannot hear me, then that's a problem. Let me see if we can go to our next one while we give Nadia some time to reconnect. Okay. Our next guest, he should have his camera on, I think. I can see him. Professor Khalid Abdel Fattah. He is from MBRF, Mohammed bin Rashid Foundation. He is the consultant. He's the Knowledge and Digital Solutions Consultant at MBRF. He basically works on digital solutions to improve knowledge and knowledge topics. So very close to what we are discussing today. Let me see if he can hear us. Professor Khalid, are you on?
He's muted for sure.
He's muted. I could see his frame.
Hi there.
Hello, great. You have your 10 minutes now with Pablos. I'll just help you with managing the time, but the mic is yours.
Thank you, Jessy. Thank you, Pablos. It was a very interesting speech, and I think it was very simple and clear as well. I'm working in the knowledge domain and the content in specific in digital transformation. And as you know and mentioned in your speech, that the pandemic era might change the way how we live in the future and how we think the future. And it is all about how we can guess the future. And you have mentioned this in your examples, and it was very clear. And I think that the way we behave with knowledge as inventor, I'm talking about you as inventor, the way you are prefer that the knowledge should be produced in the future, how you produce your knowledge from your as inventor, how you think that the educational institutions like universities, the school should provide knowledge to the way that people can consume and accept in the future with this kind of changes which happen in the current situation. And as well, how do you think that the way we consume knowledge, the way we would like to read and see, you know that people doesn't like in this era to read big books like hundreds of pages. They would like to see small videos. They would like to see pictures. So from your perspective as inventor, how do you think that the knowledge should be produced, provided, and make available for consumer and users in the future?
Yeah, that's a good question. Can you guys hear me? I don't know if my camera is working. Hopefully it's working okay for you guys. Can you hear me okay?
Yeah, we can hear you.
Okay. Well, we might have to give up on the camera. I don't know if it's
I thought you said it was a fancy camera, Pablos.
Maybe
See,
it's too fancy.
Goes to show.
Try. Does that work better? I've got a backup camera here. Let's try that one.
Yeah, we can see you. I can see you, yeah.
Okay, cool. So, you know, what I think about it is, I mean, first of all, I think we do have to be at least a little bit honest with ourselves about how things have changed as far as knowledge and learning and how that's going to go, right? You know, I had to memorize a lot of useless stuff when I was a kid. My daughter has Wikipedia in her pocket 24/7. She has all of YouTube. If she wants to learn something, she's just going to watch a YouTube video and she's going to know it, you know, faster than I'm going to be able to remember it from my childhood. So that puts a fine point on what we need humans to do. We don't need them to memorize names and dates and numbers as much, but we do need them to be able to synthesize that knowledge and put it to good use and figure out what's possible and figure out what's going to work. And so I think the main mindset shift that I would look for is, how do you learn how to get a lot of shots on goal, right? So when I talk about, you know, when I was talking about guessing, what I'm really talking about is trying to find an efficient situation where you get a lot of chances to guess, right? You get a lot of shots on goal, because none of us are smart enough to guess what's going to happen. We don't know how the world's going to be, you know, even next week right now. And so we really need to be able to test our ideas. We need to be able to reason our way to our beliefs about what's going to work and what we invest ourselves in. And so, and that's why I use the examples from the software industry, because it's just an industry that, because of how it operates, is very oriented around testing, is very oriented. And that's a way to convince yourself that, you know, these experiments are worth doing. It might be hard to sell your boss on doing a lot of experiments, but it might be easier to sell them on testing. And so what you want to be able to do is, in whatever context you're in, you know, in my context, you know, in Silicon Valley, we run a lot of tests. Every startup is just a test. Every startup is $1 million experiment. And we run thousands of them just to find the ones that work, or the ones that work the best. And, for every Uber, we got 1,000 startups that didn't work. And that's okay. At a large scale, it pays off, right? And so that's how the venture capital investment model works. That's how our operation at the lab worked, is we invent 500 things a year. Hopefully one of them turns into a nuclear reactor or an Uber or something, right? And pays for all the failures. So you really want to find a context that allows you to run a lot of experiments. And businesses, a lot of times, I think their problem is the only thing they feel confident about is whatever they did last year. And so in a lot of our businesses, the reason that they're not advancing into the future and they're not performing well on innovation is that the only thing they do is a faster, cheaper version of whatever they did last year. And that is not how you're going to get to the future. So that's the main mindset shift I think is important.
Okay, perfect. I think we jumped a little bit ahead of time, but I want to thank Professor Khaled. Thanks a lot for coming in. We're going to go back to Professor Khaled is the Knowledge and Digital Solutions Consultant at MBRF. We're going to go back now to Nadia Salim Mbarak, who she's now going to connect through her phone, is what I'm hearing. Again, okay. She represents Abu Dhabi Port. She's the VP of the port sector. Let's see if she can hear us now, and we can hear her hopefully. Nadia, can you hear us? All right, I'm gonna give her maybe just less than a minute to try and reconnect. Okay. What I'm getting from the organizer is that she is, yeah, I'll take one more minute and ask you this. I'm gonna ask you a quick question while she's reconnecting. You have a very interesting take on education. All the typical thoughts we grew up in, my generation grew up in, as the importance of having a proper education. The more expensive your college degree is, the more chances you may have in getting into the corporate world and the businesses and making more money. And this dream we were sold that the more money you spend on prestigious Ivy League colleges, schools, the better chances you have of success. You prove all of this wrong. You prove the opposite of this. You basically tell us that our world is changing so much by the second that everything we grew up learning is now completely gone. And if you don't start unlearning what we have learned, yes, the train will pass us by. I'd love for you to spend a little time on this, because now it's time for us to educate our little kids, not on the ideas we grew up in.
Yeah, I think it's a difficult, thing to get our heads around, but, a lot of our educational structures as we know them are designed to create cogs for a machine that no longer needs cogs, right? A lot of the, just the format of our educational systems, especially in America, and I know less about the Middle Eastern educational systems, but a lot of times, what we're trying to do is make people who are irreliably turn out the same. We need replaceable factory workers. We need people who all have the same level of literacy, the same background understanding, and the same ability to be dropped into a job. And that's really not what we need humans for anymore in most cases, or less and less, I should say, because it's true that automation can do a lot of those things. Anything that's sort of repeatable, mundane, dangerous, predictable, probably a robot can do a better job, and it should do it. And we think that, or I think that robots should take over anything they can do better than a human. But that leaves you wondering, well, what are the humans good for? The truth is the humans are good for all kinds of things that robots suck at and that machines aren't good at. Humans are really good at figuring out what the next thing is that a human needs. And they're good at figuring out how to take care of humans. And they're good at being creative and figuring out how to cross-pollinate a lot of different ideas. And so we need to do that, and we need to do a better job of that. And that's really what the heart of innovation is anyway. And so right now, robots suck at innovation. So let's have our humans do a better job of that. As far as kids go, I think, we got to give up this notion of making them all turn out the same. I
Yeah.
That's not at all what humans are built for. And it's really ruining us. You know, when you look around in your life, the people who you value the most are not the ones that are the same. They're the ones who are different. And so, you know, let your kids be a little different. And I mean, look, I don't know, my kid, all I do is I just watch her and see what she's excited about, and I add fuel to the fire. I don't worry about, I mean, she's 14 years old now. I don't worry about whether, you know, it's commercially viable or going to get her into college or going to get her a job. If she's interested, her brain will light up and she'll learn. You know, that's why I was able to learn a lot, because, you know, I got a computer when I was a kid. I thought it was interesting. And I spent 16 hours a day trying to figure out everything I could about the computer. At the time, nobody even knew what a computer was. I had a skateboard and an Apple II computer. And people thought maybe the skateboard wasn't as big of a waste of time. So I just think, you know, what we need our kids to do is learn how to learn, and they need to be able to recognize that, you know, brains are good at learning things they're interested in. And we have schools set up to make kids work on things they're not interested in. And that's working against us.
That's true. That's why we're seeing a lot of return on or emphasis on passion in business, passion in education, passion in upbringing. You have to have a passion for something you're doing. Okay, look, this is, I did get Nadia's question just in case we cannot hear her. It was sent to me via WhatsApp, but I do see her. And
hello.
Hello.
Hi, Nadia.
Hi there. How are you? Can you hear me?
Yeah.
Yes, finally. Okay, welcome to you. We've introduced you so many times. Nadia Salim Mubarak, welcome
so
to the VP of the ports sector, Abu Dhabi ports sector. Go ahead. You have a few minutes.
The problem is, the shame is, like, I'm a VP for the IT and I'm the only one who's struggling.
It's okay. I know. Okay. I'm on my backup camera. It's all right.
All right. Thank you so much for your time and for your valuable information that you have providing us. I'll talk today not as a port company, more than VP for IT for such like 20 years, and my experience with technology and with people. So I was talking like with my team for the past like 18 years. I was working and leading people, technical people, softwares, applications, more into technical things. 2020, I have decided to change my career path into business line, which is more into business solution, not technical people, not even leaders for any sort of tools. So I found out, why did I do that? Because when we were in the IT, it was very difficult for us to do the digital transformation easily, to be honest. We were investing a lot, and sometimes we succeed, sometimes we fail. I found out, like, now these days and this year's, I think people transformation is much important than the digital transformation. So, and although it is like a difficult things, because no use of the investment that you are doing if the people are not using or utilizing or even accepting this change better. So I found out, like, even now in the people transformation is much better than digital. So I want to hear from your experience as someone who's more into the same field and speaking the same language. What is the challenge, or what's the main key that helps you to do this change with the people transformation, not the digital? This is one thing. Second thing, in terms of the port cluster or the port companies or port all worldwide as a standardization, it's almost the same mandate, the same work. Do you have any specific model you think that it was successful model for you in terms of the integration, security, business model, something like that?
Well, I think tying a couple things we've talked about together here, people are evolved to work with other people and to have connected relationships with other people. And we've done a lot with technology to make it, possible for us to connect. You and I are halfway around the world from each other right now, talking to each other on video call, which is great. But the truth is, we're evolved to have a much deeper connection, right? And I think a good way to understand that is, probably you haven't made any new friends this year. You've been on a lot of Zoom calls.
No.
You and I, you and I are going to be acquaintances after this, but not really friends. If we had had lunch together or spent an evening at dinner together, then we would probably be able to build a friendship pretty quickly. But all these hours on Zoom, we still can't do it. And what I think is going on is, there's really deep neurological cues, things that are evolved over a long period of time. And an example is, right now, there's a lot of latency in our connection. Your brain can only handle about 180 milliseconds of latency in the sound before it starts to really get confused and question whether I'm even real. I might be a cartoon character that you're watching on TV right now, because every conversation in human history was zero latency until this last century, right? Always face-to-face, always high fidelity, no band pass filtering or compression artifacts or jerkiness or any of that stuff. Every conversation was real, and our brains are looking for that. Our brains are trying to connect. That sense of human connection is being eroded by a lot of these tools more than it's being helped. Now, when you know somebody, a family member or friend, and then you call them or you talk to them on Zoom or FaceTime or something, your brain is connecting this call to the model in your head of that person that you have had lunch or dinner with, that you have spent time with. And that sort of works. And so it's more possible to use these tools to maintain relationships than it is to build them. And so I think one of the big issues that, is really important for folks like you to be working on is, you've got these big companies, you've got people spread around the world, and it's going to be really important to be sensitive to the fact that, folks like you and I who have big networks and know a lot of people, we can kind of coast on that for a while, but it's really difficult to build new relationships that are high quality, to build that trust, to make people feel like they even want to work together and support each other with the tools that we have. So we have a long ways to go with technology to close that gap so that, this type of experience can be better. And we have a lot of work to do, adopting those things over time. But in the meantime, I think, you've hit on something really important to focus on, which is how do you support people? And I think it's about facilitating that human connection. And it's harder than ever now because of the constraints that we have from the pandemic. So hopefully that gives you some insight about where to focus.
Yeah, it is. Thank you so much. And I have also one small question. You were talking about the standardization for the technology and the applications and all of this. And most of the people, especially if they were not non-IT people, when they heard what, like, for example, Oracle, then they say, we want Oracle, let's say.
Yeah.
They only follow, they don't lead it based on their experience with that application or their environment, if it's possible to use Oracle or not. So following the people based on what they have is different, and it's difficult. You need to understand that the tools is not suitable for you, and you need to build your own tools. So I prefer from the technical or leaders of the technical people to have a standard. Most of the time, I'm trying to have standardizations better than having my own tools. But of course, we have a specific industry where we have to have our own development or something like that. I was trying to minimize the development, the internal development, or even to have our own, because in certain way you will struggle. So what do you think of
well, I think there's two things there. So when I was referring to standardizing before in the context of steel industry and their products, a good analogy actually might have been your industry, because if you look at what the shipping container did for transport and logistics, it really standardized and made it possible for the global trade that we have now. I mean, there's hardly a creation in human history that's been more impactful than the shipping container, because it's standardized and everybody could figure out how to work with it. And now your trucks, your cranes, your ports, your boats, everything are built to handle that. And so that's what I meant by standardization. Now, what you're referring to is a different context. And actually, I think the way that, when you look at IT departments up until a few years ago, they all believed they needed to run their own, infrastructure themselves on their own data center and have control of everything and manage it. And, it was very difficult to get them to transition to cloud services where it's not all under their control anymore. But I think what you're seeing now is most organizations are not like yours. They're smaller, they're more nimble, and even the big ones, they're using a wide variety of services, and the constituents for those services are inside and outside the organization. So your ability to set standards is going to be broken down pretty quickly by the fact that you need to work with a bunch of other companies that have chosen different standards. So the way we're dealing with that in the tech industry has been pretty fascinating evolution with what we call microservices. And when you look at the primary example or case study for this is Amazon. Amazon used to have pretty big monolithic services like Oracle or what you described there. Now, what Amazon has done is they standardize on HTTP. Everything in the entire company has to be a service that speaks something like REST on HTTP. And that means you can build anything you want, whatever programming language, whatever operating system, whatever database, whatever you want, doesn't matter. It talks to everything else via HTTP. And so so you standardize on the interface, you standardize on the language that the components use to talk to each other, but behind that, it could be anything. And that has really allowed Amazon, as you see, I mean, they roll out new services every day. And that's because they don't have to standardize on a language, on a OS or anything other than, they need to have well-defined interfaces. So that might be an analogy, at least, as a way to think about how to advance into the future, because for almost everything in the tech industry, that's kind of how where we're headed.
And it's certainly hard to keep up with it, for sure. I want to thank you. This conversation can never end. It's so interesting, but unfortunately we ran out of time. Yeah. Thank you so much, Nadia, for this. For you coming in and checking with us as well today. Pablos Holmen, inventor, futurist, hacker. Good luck with all the wonderful projects you are working on. We're sure to be hearing from you in the next few months and years. Do not stop. Keep going. Keep innovating. We will try to follow suit as well. Thank you so much for the KnowTalks and the Mohammed bin Rashid Foundation and the UNDP for putting this webinar together. I'm Jessy El Murr. Thank you so much for watching, and good night to you, Pablos. I know it's late in the channel.
Thanks, you guys.
Thank you all. Thank you. Take care. Good night. Bye-bye, Pablos.
Bye.
عندنا الصليل.